Ladies and gentlemen, thank you very much. I spent the last almost 2 years living in a world 2050, 2100, and my project was more of a futurist, trying to understand the changing dynamics of all these things that we heard today, renewables, Internet of Things, electric cars, et cetera. And through this process, what I did is I sat with a blank canvas like a painter, started taking bits and pieces of all the dynamics, all the underlying factors that essentially could influence what the natural gas world will look like in the future, and started painting a canvas. And out of the canvas emerged Novatek's strategy to the year 2030, and that's what I'll run through briefly with you. But in this period of time, looking at India in the future, India has a tremendous opportunity, not only in the terms of its population growth, because in this period of time, India will be #1 in the world with over 1.6 billion people, but it has a chance, if it adopts natural gas, to build up its industrial base, but you have to solve the infrastructure problem of moving gas within the country. I know you alluded before about the prices being too high, and I think that also needs to be addressed, because it's not only a reputation damage to the country and to its buyers, it's also incumbent upon the industry to be able to develop natural gas reserves cheap enough to be able to develop and sell to the world. So I really started off with three questions that we really wanted to tackle, primarily three main questions. Is we have 3.3 trillion cubic meters of natural gas, and how do we monetize that in a cost-effective manner? We also need to look at, since we're in Siberia in the Arctic zone, how do we bring that gas to market is through LNG. So how do we reduce the liquefied cost in a range of about 650 million to 750 million per ton? Then we're looking at the infrastructure of how do we move the product around the world, and finally, some of the things that are happening in a trade. All those go back to what Dr. Mentisher talked before about the trilemma. It's energy affordability, energy security, and energy sustainability. And we believe we can answer all those questions as we move on. I know there's a typo on the presentation, but it's actually 23% on the gas. It doesn't really change much, as you rightly said. Gas doesn't really change much, but it is the only fossil fuel that is actually increased. It's increased in a tune of about 802 million tons of oil equivalents. We'll see that on an average basis, renewables increases, but if you go from 1 to 2, you doubled. So where we're going from is from a very low base, and we're seeing some penetration in renewables, but there's still a lot of questions that we need to address in order to make sure that renewables will be a fuel that solves the intermittency problem of power generation. But your Prime Minister Modi basically said the next generation fuel is natural gas, and he even recognizes the point that I raised about how do you build the infrastructure within your country so that you can actually move hydrocarbons around the world. We also talked about, as you started off, that it went as high as 10, 11%, but on average, gas has been about 6, 7%, but we hear recently that there's a plan to raise it to 15%, and if we raise it to 15%, it changes the complete dynamics of the supply side for the country of India. Unfortunately, the energy minister wasn't here this morning, but he said gas is the cheapest fuel, and taking into consideration environmental impact. And that's one of the key questions, because I don't think, I'm not here today to sit there and criticize the coal sector, or the crude oil sector, et cetera, because each and every one of us has a role we play, whether it's transportation fuel, because that's not going to get replaced, petrochemicals, plastics, et cetera, and the coal, as you heard on the last panel. We are doing something today in the fossil fuel world that's cleaning the coal to make it acceptable. So there is sufficient reserve supplies around that we need to deal with, but we need to deal in a responsible manner, and I think the industry is tackling those types of questions. I'm going to focus not on natural gas per se, but mostly on LNG, because in the country of Russia, where we operate, Gazprom has the monopoly on the pipeline. We have the access to the exports of LNG. So over this period, looking at this canvas that we were painting, we basically said that there's over 300 million tons of LNG that's coming onto the world. This supply says it's about 200 and something coming from 2016 to 2030, and that 79% of this supply that needs to be delivered to the market will be the Asian Pacific region. We actually think this is quite conservative, and we believe by the time we reach at the end of the decade, we'll start seeing revisions because the so-called glut that everybody talked about in the natural gas industry has not really materialized. To say, matter of fact, what we're seeing is that there is shortages of moving gas to particular markets, and as a result of that, we're seeing that the natural gas prices have increased. Ironically, we launched a project recently, and our gas in Russia, which none of us ever thought about, I was promised 10 years ago that if we did this project, the first tanker to go to the United States, I would be on it as a US citizen. Unfortunately, that did not happen, but the first tanker went to the United States, and none of us knew that's where it was ended up going to be. It ended up landing in Boston. But when we look at India, what we're trying to do, we're trying to map around the world, how do we deliver hydrocarbons from the Arctic region, and how do we deliver it competitively into the particular markets that we want to deliver? You know, we can go to traditional route through the European Union, round through the Mediterranean, through the Strait of Malacca, once we cross through the Suez Canal, up to the Asian Pacific market. Primarily target about 80–85% of our LNG will eventually make it to the Asian Pacific market. Or what we've done in 2010, we were the first company that actually transversed hydrocarbons through the Arctic Ocean, the Northern Sea route. And by doing that, we were able to reduce the logistical time by 50%. So we were able to go from what would take us normally about 36 days down to about 18 to 19 days by going through the Northern Sea route. But in order to do that, we had season problems. We can only do it at certain parts of the season, and that was maybe 5–6 months at best, maybe from May through end of September, early October. But in our project, we developed ice-class tankers, and I'll show you a picture of it later, that actually, what we believe by the middle of next decade, will be able to run through the Northern Sea route 12 months a year. But India is an interesting market for us. We're in the process, we're going to be building this transshipment facility, but India has various options to look at its natural gas. If we look at Mozambique as one example, it's a big country, big resource base, but it has no projects. And that's one of the things we have to worry about ourselves. There's a lot of projects on the drawing board, but they're not really built yet. Qatar is actually a natural market, as well as some of the Australia. We believe when we build our transshipment facility, India can have call on our natural gas. But now one of the things we have to do, though, is how do we unlock some of this stranded capacity on the gas power plants? We see, as rightly said, there was a lot of discussions on coal. Coal plays a very large role, but according to the energy policy, the national energy policy to 2022, coal actually decreases. Renewables, natural gas, et cetera, nuclear increases. Now again, it's not meant to be a negative to the coal sector because coal will be the fundamental basis. But if we look around the world today, one of the problems that we've seen in China, as an example, when we talk about COP21, we're talking about two ways to solve that particular problem. We're talking about whether or not it's going to be a top-down governmental approach to climate change, or will it be a bottom-up economic model. China went recently with the top-down approach, no coal being burnt in 18 major cities. What happens? We have a dislocation of product, prices go up, and now we have China importing, overtaking South Korea as the second largest buyer of LNG, and eventually will be number one. Now, I think India will be the opposite side. India will be a bottom-up model, although Modi has basically said in some of his other speeches that he wants to see natural gas increase to about 15%, but you have sufficient coal. You have to be able to utilize that properly within a mix, and that will be your base. So I believe coal will be always the fundamental base here in this country as the economic model builds up, but natural gas will play an increasing role, and we would like to be part of that. So in terms of production centers, and when you look around the world, obviously there's, LNG produced in many, many locations, but these are the four main primary market centers. I showed this slide in Singapore about 3 weeks ago, and some gentleman was like upset a little bit because I didn't have Mozambique on it, but I brought the same issue. Mozambique is not producing today, and therefore I don't consider it a main center. But we got, you know, obviously the United States with its export policy under President Trump. President Obama talked a lot but didn't do anything. Trump is a man of action, more pragmatic, and I think he has an export-focused agenda. We have Australia, but Australia turned out to be high cost, overruns, delays, and I think eventually Australia will be capped in what it can do in terms of its capabilities. Then you got Qatar, who has a chance of debottlenecking some of its particular facilities, plus develop a little bit more of the North Field. And then you have Russia. And out of Russia, essentially what we're looking at is Novatek leading the way. But what's changed dramatically in the LNG world, which is obviously a big question that we look at when we're developing the marketplace, is that contracts are changing. We're seeing shorter duration contracts. We're seeing, you know, smaller volumes. We're seeing people moving. 35 new countries started importing LNG in the last 5 years, but that obviously impacted the credit qualityness of these particular countries, and we have to take that in consideration when we start looking at the financing of some of these very, very large capitally intensive projects. But the bar graph is a little interesting because what it really shows us is that there's about 80 million tons of LNG coming off contracts. In our assumption, in building up a model from a bottom-up approach to try to determine where we fit into this equation, we assumed that the seller will retain its buyer, but at a different price. Now, that may not be 100% accurate. We may be able to come in and take over some of these contracts, but the assumption was is that the seller will retain. There's about 80 million tons of this that needs to be replaced. So we see this paradigm shift. It's a real. We're moving away from oil linkage. I have a lot of traders that question that comment I make because they see maybe more of a hybrid approach to LNG pricing. But one of the things that's been pretty evident is that we've been averaging about 25% of the volume traded is spot. And we see that in the next wave, which we call the second wave of projects, that the majority of sales will eventually be spot sold. So we're seeing big changes led by countries, led by the big importing countries of Japan, Korea, and one of the things that we're going to see that absolutely going to change is this concept of flexibility. So we're going to move away from this destination clause, allow countries to be more flexible in their buying, where they move it, but it'll be at a more of a probably hybrid price. But definitely contracts are moving away from 20 years down to more like 1 to 3, 5 to 10 range, and we have to deal with the financing world so that they understand that that's the case. So in our strategy, what we presented, so it's a little different now what I'm going to do, because what we saw this morning was governmental policies, talked about it. Next panel, we talked a little bit about what consultants do. The panel before this was essentially more or less think tanks. Now I'm going to show you some concrete projects that we're actually working on to build up this particular business of ours, this global LNG. So on December 8th, we launched the first tanker from our Yamal LNG project. This is a project that we heard nothing but doubters, skeptics, and critics. Everybody said it cannot be done. It was impossible to do. You won't get any partners. You'll never sell any contracts, and you'll never get any financing. And we completed this project on time and on budget. The only one in the world that has been able to do that. This is a Christophe de Majoret. It's a specially built tanker built in South Korea at DSME. It's basically called an ARC-7 ice class tanker that allows it to go into and crush up to 2 meters of ice by itself. Now, we'll have icebreakers working along the way, but this is the one that we did, and this was actually the photo of the evening when we actually did the formal christening of the vessel on the 8th of December. So Yamal, again, was done on time and on budget. It was roughly about 27 billion. It's 3 trains, 3 LNG trains, 5.5 million trains. We're adding on a 4th train, which is based on Novatek's technology. It's slightly under $1 million. The partners in this particular deal are Total at 20%, CNPC at 20%, Silk Road Fund at 9.9%, and Novatek owns 50.1%. This is the flagship project coming out of Russia. This is what got everybody concerned about developing it in the Arctic zone, because this now sets the table for us to move forward with how do we develop the massive resource base that we have on the Yamal and Gyetvay Peninsula. As I mentioned, we have about 3.3 trillion cubic meters of natural gas, so resources are not the problem for us. The problem is how do we successfully monetize these gas assets in a cost-effective manner so that we can deliver product to the market of India at the most cost-competitive price so that we can start penetrating and create demand inside of your country. It's a really unique area because it's built on permafrost. And what we did with Yamal, we had to drill 38,000 pilings, precision drilled. Each piling had a heat exchanger on it so that we can regulate and modulate the ice zone and don't melt the ice cap. And as a result of that, what we've ended up doing, we had this massive footprint that we built on inside the land base. We decided to move forward with that and change that. So these are like the lessons learned from the project. We're going to move forward to an idea on Arctic LNG 2, which is based on what's called the gravity-based structures. They're basically units that would be built, large barges, 300 meters in length, 150 meters in width, 60 meters in depth, with about another 60 meters on top side. And what they'll do, they'll be anchored about 500 meters off the shoreline, and the Arctic LNG field, which is the Utrane field, will produce about 30 billion cubic meters of natural gas. It has the equivalent of producing over 19 million tons per annum. So this is a massive project that we're underway. You may have read with interest is yesterday in Saudi Arabia, there was a meeting amongst the ministers, Novatek, et cetera, for Russia, and there's announcements that are coming that potentially Saudi Aramco might be interested in joining the Arctic LNG 2 project. So the GBS system, again, it's a floating barge. It's not novel technology. See, that's the question that we always are addressing as we do these projects. Just as we did with the ice-class tankers, all we did was take an existing tanker, modify it to meet the conditions of the Arctic zone. The same thing we're doing with the GBS structures. The GBS structure is already used in Adriatic LNG. It's already used in the Asian Pacific market as a gas processing facility. All we're doing now is developing, tailoring these GBS systems to be able to withstand the tension, the size, the tank, et cetera, to hold all the units inside of these particular vessels. This is what it will look like on a 3D graph. They're basically going to be docked on the side, like I said, about 500 meters off the shoreline. We've already found the exact zone. We did all the soil testing. We have to dredge about another six to 9 meters of soil to get down to the flat bed. You see those white lines are actually ice barriers. They'll need to be built so that when we see floating ice, they don't crash into the GBSs as they're parked and docked. And then the vessel, as you see coming in, actually pulls up to the side of it and loads up and then backs out again. The harbor will be monitored 24/7, 365 days. It'll have ice-breaking capabilities if and when. So there'll always be dedicated icebreaker facilities by the Russian government that's going to ensure that the lane is always open if and when we have problems with the ice. We have a lot of time, my friends, that there's not ice zone. Maybe that's a result of climate change, but the reality is that we can probably go 5, 6, 7 months now without having to worry about having a icebreaker. Matter of fact, on the test run that we did on the Christophe de Majerey, that vessel I showed you, it went through the whole northern sea route, crushing through 2+ meters of ice without any icebreaker capability. So these vessels are pretty sturdy. To make this cost effective for us, what we're going to do, we're building this LNG construction center in Russia. On Yamal LNG, we had over 100,000 people around the world work on the project. we had fabrication yards all over the place, and modules were coming back and forth from the unit being constructed, tested, delivered to your mall. What we want to do to reduce costs, control the process, et cetera, we're building this construction center inside Russia, localizing the expertise onshore, so we don't have to worry about any more threats of sanctions. We don't have to worry about any threats of delays in deliveries of products, et cetera, or modules. We'll do it all onshore. We put together a consortium. It's called Nova Engineering LNG. It's made up of Technip FMC, Linde will use their technology for the liquefaction, and then Nipi Gas, which is a Russian institute, and also Saipan will be a subcontractor to that particular project. This will create, on the Russian territory, over 5,000 new engineering jobs, over 10,000 new construction jobs, as well as across the whole country, it will build economic base for the development of this new infrastructure that is being built and localized in the country of Russia. Second major thing that we're doing in terms of how do we bring product to the market in a cost-effective manner. What we do, as I said before, when we go through the European side, we do not bring these big ice-class tankers all the way to the end market. No need to go through the Mediterranean with a big ice-class tanker. So what we end up doing, we transship over to Zeebrugge in Belgium, we offload onto conventional tankers, and then conventional tankers basically take it to the end market. What we're going to do at this new facility that we're going to build on the far east of Russia in Kamchatka is basically do the same thing. We're going to build a transshipment facility that we can now go back and forth between our operations and this transshipment facility. So therefore, at the point of ice, no ice, we can then offload to conventional tankers, reduce the cost, reduce the amount of boil-off gas, sell the boil-off gas that we have already to the local markets, which will have about 400, 500 million cubic meters per annum. And this idea also creates a Russian LNG hub price. Remember what I said earlier, we're moving away, in terms of the change in conditions, we're moving away from oil linkage and we're moving into more hub-based prices. This is a couple of schematics. It's basically a QMAX ship, hulled out, storage facilities. The ARC-7 comes at the side, conventional one with the round tops comes on the other side. It's a ship-to-ship transfer. It's about 20 million tons. We have the capability of expanding it up to 40. So that's another just a graphic location. And the city is on the side of it, and we'll deliver gas. We'll build a pipeline directly into the city. So the logistics all change. And what this actually means to us, as we go through and look at the marketplace to make our gas competitive, we've reduced almost 80 cents per MMBTU off the cost of logistics by building this Kamchatka facility. And that allows us, again, to eliminate all the additional costs that would go through the Suez Canal, plus save boiler-off costs, plus save transshipment costs, and tanker costs, charter costs, because we will not have these long distance on these big tankers anymore. So this is actually a pretty good project, and we're looking at partners who's going to join us on this particular project. So this might not be a fully integrated, this might be a standalone facility, but this will be integral to our logistical model moving forward. So what have we done? So based on what I showed you today, we believe we have answered the questions of energy affordability, energy security, and energy sustainability. We have been and will be the lowest cost producer of natural gas in the world since we went public in 2005. We either ranked #1 or within the top 5 every year by the IHS Herald reports. So we know we can deliver cheap feedstock gas to the marketplace. When we look at the changes in the marketing structure, everything, the key word is flexible. Flexible terms, flexible volumes, flexible pricing, et cetera. That flexible volumes, that has to be in place today to facilitate the change in marketplace. Buyers want delivery of product on a short-term basis. They want to be able to go in. Japan wants to be able to come in and say, I need a cargo in 3 days. Can you deliver? The answer is yes, we can. South Korea, can we deliver it in 3 days? The answer is yes, we can. So they do not have to go out and contract long-term contracts anymore because we can deliver it to the market at a pretty quick pace when and if they need it. The Kamchatka facility will facilitate that as well as reduce costs. But the most important thing with the GBS structures that I wanted just to end the conversation with today is that it's scalable. You know, we're not going in and making this massive cost of capital into a big project without a marketplace. So the scalability allows us to look at the market and come in and say, how many GBS systems do we need to put out and build in the next 2 years? And so now, because the market's changing, because the market's moving away from these long-term contracts, we need to do this. And I believe that this idea will allow us to look at this with low cost to answer these 3 questions. Thank you very much.